Hello everyone. I welcome you all to week 3 of the course Maintenance and Testing of Electrical Machines. So in the previous 2 weeks you all have learned about the basics of transformer, its working, its construction, its various types, the phasor diagram related to transformers on the resistive load, on the inductive load as well as on the capacitive load. Then we have discussed about the various tests to be performed on the transformers like the open circuit test, short circuit test to determine the various losses related to the transformers. Now in week 2 you have learned about the efficiency of transformer and the voltage regulation associated with the working of transformer. After that, we have discussed about the 3-phase transformers in which we have covered the basic principles of 3-phase transformers, their workings, their advantages, disadvantages, and also we have discussed about the single phase supply as well as 3-phase supply. After that, we have discussed the auto transformers. So basically these auto transformers have some or the other advantages and disadvantages related to their operation as compared to the 2-winding transformers. So up to this part we have covered in the previous 2 weeks. Now in this week we are going to cover a very important topic related to transformers, which is known as the instrument transformers. So dear learners, in this lecture we will discuss about the various instrument transformers which are used in our day-to-day life or in the power system. So I welcome you all to this lecture. Let's move ahead. So we will discuss about the instrument transformers. So in this lecture we will be discussing about the instrument transformers, which is a device that steps down high voltage and current from power systems to a manageable level for measurement and safety. So we will also discuss the advantages. Basically the instrument transformers standardize measurements, reduce equipment costs and enhance operator safety by providing electrical isolation. Also we will discuss the types of instrument transformers, which are basically current transformer and potential transformer, and they both have been designed for specific measurement tasks. Safety and functionality. So these transformers include safety features such as grounding and operation under specific circuit conditions like short circuited for CTs and open circuited for PTs to ensure accuracy and prevent accidents. So these all are the topics we are going to discuss in this lecture. So let's start first with the instrument transformers. So the instrument transformers are designed to transform voltage of current from the high values in the transmission and distribution systems to the low values that can be utilized by low voltage metering devices. There are 3 primary applications for which ITs are used. So the first purpose is for metering, like for energy billing and transaction purposes. Second one is for protection control, which is used for system protection and protective relaying purposes. And also the third purpose is load survey, that is for economic management of industrial loads. So these are the 3 purposes for which we are going to use the instrument transformers. Depending on the requirements for those applications, the IT design and construction can be quite different. Generally, the metering ITs require high accuracy in the range of normal operating voltage and current. The protection ITs on instrument transformers require linearity as a wide range of voltages and currents. So during disturbance, such as system fault or over voltage transients, the output of the IT is used by a protective relay to initiate an appropriate action, that is open or close a breaker or to reconfigure the system, etc., to mitigate the disturbance and protect the rest of the power system. So mainly these instrument transformers are required or used as a sensing device. So basically in the power system we have the two major quantities which needs a frequent monitoring. First one is the current and second one is the voltage. So if any fault occurs, then obviously the magnitude of current will rise and it will affect the equipments or instruments connected to the utility supply. So it is a very much basic requirement for any power system to sense the current and the voltage in that particular system. So these CTs and PTs are basically used for sensing the current and voltage in a particular power system. So the instrument transformers are the most common and economic way to detect a disturbance. So if we talk about the levels, so the typical output level of instrument transformers are 1 to 5 amperes and 115 to 120 volts. So for CTs and voltage transformers respectively. So means the range of output for a CT or a current transformer is from 1 ampere to 5 amperes, and for a potential transformer it is 115 volts to 120 volts in the output. So there are several classes of accuracy for instrument transformers defined by IEEE, CSA, IEC and ANSI standards. So to explain the basic working of the instrument transformers, there is a figure. So in this figure or diagram, it shows the basic usage of instrument transformers. So mainly they are used to transform the primary voltage or current to values that are suitable for measuring instruments such as voltmeter, ammeter, wattmeter, energy meter, power factor meter, frequency meter, etc., and protection relays and control equipment. So mainly if we talk about our power system, the level of voltage and current is very much high. If we talk about voltage, it is in the level of megavolt, kilovolt, or in terms of high voltage and current. So to measure these voltages and current, we require the measuring instruments up to that level. So if we make the instruments up to that level, then it will be very costly and it will not be economical for our design. So what we do, we just use this instrument transformers to step down the voltage and current for the measurement purpose. So for this purpose also we are going to use the instrument transformers, and in addition to that they can act as isolation between the instruments and high voltage circuit. As you all know, if any instrument or equipment is connected electrically with the main power system, and if any kind of fault occurs in the main power system, then it will directly or indirectly affect your instruments or equipments, and it may cause a permanent damage to the equipments. So these instrument transformers acts as a isolating medium between your supply and between your equipment. So these are very helpful in this regard also. And in addition to this, the basic merits mentioned above, it has a commercial advantage also. So power generation, transmission and distribution networks have different voltage level. So designing instruments that can safely operate at all these voltage levels and maintaining a huge inventory is highly impractical. So To cater this problem or issue, the manufacturers design instruments suitable for 120 volt or 5 ampere, which in combination with suitable instrument transformers can be connected to high voltage and high current circuits. So, the usage of this instrument transformer serves many of the purposes for the measurement, for the protection, for the economic viability. So, all these issues and challenges can be catered by using this instrument transformers. So, this is the basic details related to the instrument transformers, and now we are going to discuss the types of instrument transformers, which is mainly a current transformer, which is also called as CT, and potential transformer, which is also known as PT. So, we are going to discuss the two types of instrument transformers. So, first we will discuss about the current transformers. So, the current transformers or CT are basically the transformers that are used to transform currents and are known as current transformer. So, they are used to reduce high current to 1 ampere or 5 ampere, so that they can be measured using an ammeter or used in the other control circuits. So, this basically explains that irrespective of the input level, the output of a current CT is only 1 amperes or 5 amperes. So, if we are having some high current at the input side like 200 amperes, 250 amperes or 300 amperes, then this high value of current is converted or is stepped down to this 1 ampere or 5 ampere, so that it can be easily accessible by the instruments for the measurement purpose. So, it consists of a single or fewer primary turns and large number of secondary turns. So, in this case the primary turns are low and the secondary turns are high or in large number. In most types, the current carrying conductor itself acts as the primary winding of the transformer. So, the current carrying conductor can be used as a primary winding for this instrument transformer. The primary of the current transformer is connected in series to the line, while the secondary is connected to the measurement, control or protection devices. So, the primary of the current transformer is connected in series, and while the secondary is connected with the measurement devices. Now, the current transformers serve two purposes. So, the first one is it facilitates the measurement of high current, and second one is as a insulation of meters, instruments and protection relays for high voltages. So, it also provides insulation to the meters and instruments from the high voltage levels. So, these are the basic two purposes of a current transformer. Now, for a short circuited transformer, there is a following validity or condition. So, mainly this equation gives current transformation in proportional to the primary and secondary turns. So, mainly in case of current, if we talk about the current, so the current is inversely proportional to the number of turns. So, in case if we have a large amount of current at the primary side, then obviously the number of turns will be low, and if we talk about the secondary side, if we are stepping down the output current, then in that case the output turns or the number of turns at the output side will be more as compared to the primary side. So, there will be a inverse relation between the current and number of turns in case of this current transformer. So, if we talk ideally, a current transformer is a short circuited transformer where the secondary terminal voltage is 0 and the magnetizing current is negligible. So, in case of CT, the secondary terminal is short circuited, means the voltage across the output terminal is 0 and the magnetizing current is negligible. Now, we will talk about the types of CT. Now, we are going into some depth to this CT. So, we will discuss the types of CT available. So, the first type is window CT or toroidal CT. So, basically this window CT or toroidal CT is a hollow core through which the current carrying conductor or cable is passed. So, it is a kind of ring size or a window size, so that the hollow core through which we have to pass the conductor through that hollow part and the secondary winding is in that hollow core. So, this is known as the window CT or toroidal CT. Next one is bar CT. So, basically this contains a copper or aluminum bus bar surrounded by the secondary winding wound over the ferromagnetic core. So, this is mainly the bar CT. Now, we are going to discuss about the wound CT. So, this wound CT have a separate primary and secondary winding. So, these all CT types are visible in the figure. You can refer the figure to understand the basic construction of these CTs. So, now the secondary circuit of the current transformer must never be opened while the transformer is excited by primary current. So, there is a protection which is required for this secondary CT, for the secondary side of the CT, that it should be never operated in a open circuited condition. So, why this is required? Because due to higher turn ratio, high voltages are induced at the secondary, which may be hazardous to insulation and to personnel, and because the accuracy of the transformer may be adversely affected. So, for this reason, the current transformer is never operated at the open circuit condition for the secondary side. So, this may be hazardous to insulation and also to the personnel working across this CT. So, this is all about the current transformer CT. Next, we are going to discuss about the potential transformers or voltage transformers. So, the instrument transformers that are used to transform voltages are known as voltage or potential transformers. So, mainly they are used to reduce high voltages to 120 volt or other lower levels, so that they can be measured using a voltmeter or used in other control circuits. So, mainly it consists of a magnetic core upon which a large number of primary turns and fewer number of secondary turns are wound. So, they are designed for optimal performance with high impedance secondary loads. The primary winding of a voltage transformer is connected in parallel with the load for which the voltage is to be measured or controlled. The secondary winding is connected to measuring instruments and control devices. So, for example, we have discussed the CT in which the current transformer is connected in series with the supply, but in case of voltage transformer it is connected in parallel with the load. So, the CT is always connected in series and the PT is always connected in parallel. So, these are the two main points related to the instrument transformers. Now, for a transformer in no load, the following is valid. So, the equation gives the voltage transformation in proportional to the primary and secondary turns. So in case of voltage transformer, the voltage is directly proportional to the number of turns. So if the input voltage is high and the output voltage is low, so it will directly reflect on the number of turns. So in that case, the number of turns at the secondary side will be low for the step down operation. So the equation shows the basic voltage transformation ratio in case of potential transformer. So a voltage transformer is ideally a transformer under no load condition, where the load current is 0 and the voltage drop is only caused by the magnetizing current and is thus negligible. So this is all about the potential transformer. Now we will discuss about the difference between a current transformer and a potential transformer. So the first difference is that the current transformer is connected in series with the power circuit and the potential transformer is connected in parallel with the power circuit. The second difference is the secondary is connected to a meter, and in case of potential transformer, the secondary is connected to voltmeter. Now the third difference is the secondary works almost in short circuited condition. So in case of CT, the secondary side is almost short circuited, and in case of potential transformer, the secondary works almost in open circuited condition. So this is the basic difference, like the CT is working in a short circuited mode and the potential transformer is working in the open circuited mode. Now the fourth difference is the primary current depends on power circuit current, and in case of potential transformer, the primary current depends on secondary burden. So we will discuss the term burden in upcoming part. So the basic difference is that the CT current depends on the primary current and the potential transformer's current, primary current, depends on the secondary current. As far as the secondary loading is there, the amount of primary current will increase or decrease according to the load or burden connected at the secondary side. Now the primary current and excitation vary over wide range with change of power circuit current, and in case of potential transformer, the primary current and excitation variation are restricted to a small range. So in case of CT, the variation is in very wide range, but in case of PT, the variations are restricted to a smaller range. Now the sixth point is one terminal of secondary is earthed to avoid the insulation breakdown, and in case of potential transformer, one terminal of secondary can be earthed for safety purpose. Now the final point is secondary is never be open circuited. So we all know that we cannot operate the current transformer with the secondary open circuited due to the insulation and safety concern, and in case of potential transformer, this secondary can be used in open circuited condition. So these all are the basic differences in the working or principle of a current transformer and potential transformer. So now we are going to discuss some terminologies which are related to instrument transformers, like burden and accuracy. So if we talk about the burden, so the rated burden is the amount of load that can be imposed on the secondary of the instrument transformers without causing an error higher than the defined by its accuracy class. So mainly a burden is the amount of load that can be given to the secondary of the instrument transformers. So this is the burden. Now the accuracy class. So the accuracy class describes how accurate the transformation of the instrument transformers would be when the burden within the allowable limit. So the accuracy of a transformer or instrument transformer can be decided by the burden allowing the load to be in the permissible limits. So this is defined by the accuracy class of the instrument transformer. Now the polarity. So the polarity makings are done on a transformer to show the relative instantaneous directions of current flow in primary and secondary terminals. So this indicates the direction of secondary current when primary current is flowing into the marked primary terminal. So this is the basic point related to the instrument transformer. So now as we have discussed about the type of current transformers, we have some three types of potential transformers also. So the first one is electromagnetic induction type. So the principle of this electromagnetic induction type is similar to two winding transformer. So it is related or it works in similar mode as a two winding transformer. Now we have the capacitive coupled type. So in the capacitive coupled voltage transformer, it is a combination of capacitance voltage divider and electromagnetic type potential transformer. So this is a capacitive coupled type potential transformer. Now we have the optical type. So in this optical type, the voltage transformer works on the principle of Kerr effect, by which the light which is reflected from a magnetized surface may change both polarization and reflected intensity. So what is this Kerr effect? So it is also called as quadratic electro-optic QEO effect. So it is a change in the refractive index of a material in response to an applied electric field. So these are the basic three types of potential transformers which exists for our practical applications. So now we will discuss the advantages of instrument transformers. So the first advantage is they isolate the measuring instruments and control circuits from high voltage circuits. So the first advantage is its isolation property. Now the second one is manufacturers design instruments suitable for 100 to 120 volt or 1 ampere to 5 ampere, which in combination with suitable instrument transformers can be connected to high voltage and high current circuits. So making the instruments reliable and economically viable. Also, the instrument transformers ensure the safe operation of instruments and operating personnel. So they are also used as a safety precaution measure. The fourth one is the several instruments can be connected to a single instrument transformer, providing the combined burden will not exceed the rated burden of the transformer. So this one is the fourth advantage of an instrument transformer. So the instrument transformers have many of the advantages, but also it has one disadvantage. So what is the disadvantage? The main drawback or disadvantage of these instrument transformers is that they cannot be used in DC circuits. So for the DC circuits, these instrument transformers are not applicable. So for DC circuits, we have to use some other equipments or devices for the protection, measurement and isolation purpose. So with this, we have completed our today's lecture, and in this lecture we have mainly discussed about the instrument transformers, their examples, their usage, their advantages, disadvantages, and in which we have covered the two main instrument transformers which are known as current transformers and potential transformers. We have also covered their types, their working, and the advantages and disadvantages of instrument transformers. Now we will discuss some of the multiple choice questions related to this current transformer and potential transformer. So the question is on your screen that the current transformers are always used with the blank closed through ammeters, wattmeter, current coils or relay coils, and your options are primary winding circuit, secondary winding circuit, galvanometer and voltmeter. So in this case the correct option is secondary winding circuit, and we have already discussed that why we have to close the secondary winding circuits. The next question, the nominal ratio of a current transformer is, first one primary winding current divided by secondary winding current, second one is number of primary winding turns by number of secondary winding turns, third one is rated primary winding current by rated secondary winding current, and fourth one is number of secondary winding turns by number of primary winding turns. So in this we have the correct option as number 3, in which the rated primary winding current divided by rated secondary winding current. So why this option is correct? Because the ratio of the primary current rating to secondary winding current rating is called as the nominal ratio of a CT, and it is expressed as a ratio which indicates how many times the secondary current is reduced relative to the primary current. Next question, if a power transformer has a star connected primary and a delta connected secondary, then the CT connections on its primary and secondary sides should be, first option is delta and star, second option star and delta, and third option is delta and delta, and fourth one is star and star. So why here the options are, which option is correct? First one is correct, delta and star respectively. So why we are using this option 1? So if a power transformer has a star connected primary and a delta connected secondary, the CT connections on its primary and secondary side should be connected in delta and star respectively in order to nullify the phase shift of the power transformer. So the current transformers are connected in a reverse configuration. We have already discussed in case of this 3-phase transformers that if we are going to connect the primary in star and secondary in delta, then there is a phase shift. So to nullify that phase shift, we have to connect the CTs accordingly. So they are connected in a reverse direction or notation. So with this we have discussed some of the MCQs related to current transformer and potential transformer. So with this we are going to end this lecture, and we will discuss some more topics in the upcoming lectures. Till then, happy learning and thank you.